Suppose an unpolarized light is incident at the interface of the two media. This is A, refractor index is 1, and this media, the refractor index is mu. And suppose this is the normal at the interface. Part of light will be reflected back, and some part of the light will go to the other media. Suppose if the incident light is unpolarized, so its vibration has components both in the plane as well as perpendicular to the plane, and the angle of incidence is I. Electromagnetic theory tells that the component of light perpendicular to the plane, that is shown by the dots, are reflected strongly, and the components of light in the plane of the incidence are reflected weakly. So this is shown by the reduced size of this double arrow. While in the refracted light, both are refracted equally like this. So let me explain it again. Here, this is the unpolarized light. And component of light is both in the plane of incidence and perpendicular to the plane of incidence. Component in the plane of incidence is shown by the double arrow, and the component perpendicular to the plane is shown by the dot. The components of light in the plane are less strongly reflected, so that is shown by the reduced sign of these double arrow. And while there's no such case in the refracted light. Brewster showed that at a particular angle, the angle of incidence is such that I is equal to tan inverse mu. The reflected light has become totally polarized. The component of light in the plane of the incidence totally becomes zero, so it becomes a polarized perpendicular to the plane of incidence, and this is same as earlier. So here there are this component and this component, and if I apply Snell's law also, 1 into sine I is equal to mu into sine R, and here tan I is equal to mu. So if I divide it by cos I, sine I upon cos I is equal to mu sine R upon cos I, and sine I by cos I is tan I, which is mu. So what we will get? We will get sine R is equal to cos I, which can be written as cos 90 minus I, which can be written as sine 90 minus I. It means R is equal to 90 minus I, mean I plus R is equal to 90 degree. And in the question, it is given that the reflected light and refracted light are perpendicular to each other. I mean, it is this case, so it means the incident unpolarized light is incident at the Brewster's angle, which is equal to tan inverse mu. So now the correct answer is, this is not the correct answer, this is also not correct answer. And when the light is incident at Brewster angle, the reflected light becomes totally plane polarized, and the electric field vectors are perpendicular to the plane of incidence. So second is the correct option. Option 2 is correct answer in this case.